Welcome to this topic. In this topic, we will learn to identify terms and coefficients of terms. So we're going to be looking at those ones there, those two main objectives there, to identify the terms and the coefficient of terms. So first of all, we need to recall that variables and or numbers can be combined with operations of arithmetic to create an algebraic expression. For example, we may have x plus 8. This is an algebraic expression. Algebraic expression, not equation, because it does not have an equal sign. It is just an expression. So here we see variable, which is a letter, and number, which is a number here, that can be combined with the operation of arithmetic, which is addition, to create an algebraic expression. Addition symbols represent or separate expressions into parts called terms. So there are two terms here. So x is a term. So let me put it this way. This is an algebraic expression that's point 1. Point 2 has two terms. And the two terms are x as is the first term and 8 is the second term. So those are the two terms there. Okay. Since subtraction can be written, because we can say about subtraction. Since subtraction can be written as addition of the opposite, then the expression, for example, a squared minus 3a minus 9 has three terms. They are a squared plus, let me put negative 3a out here, plus negative 9 there. So these are the three terms. So let me identify them. This is the first term, this is the second term, and this is the third term. So we can identify them. In general, a term, as you can see here, these three terms here, or these single terms, is a product, as you can see, multiplication, or quotient of numbers and or variables. A single number by itself, such as 8, or variable, such as x, is also a term. Examples of single terms are, for example, 4, that's a single term, y, that's a single term. This is a term with a number and a variable. Negative w to a third power, another term. 3.7 x to the fifth, another term. 3 over n, that's another term. Negative 15 a squared, that's another term. This is a quotient. Okay, so we can say that a term is a product of numbers and or variables. Okay, that's what we can say a term is. So that's what we can say about terms. Now, the numerical value, as you can see here, the numerical value, or in this case, the numerical factor of each term is called the coefficient. So negative 3 is the coefficient. The 1 here is the coefficient. So those are the coefficients of the term. For instance, 6r has a coefficient of 6 because 6r is equals to 6 times r. The coefficient of negative 15 ab squared is negative 15 because negative 15ab squared equals to negative of 15 times ab squared. More examples will be shown as we go by. Okay, so as you can see, the coefficient of any term, such as this one here, is a 6. The coefficient of this term here is a negative 15. So that's what we mean by term. Now, given a term such a number, as in this case 8, that consists of a single number, is called a constant term. So as in, so 8 consists of a single number and is called a constant term. That's what that means. Okay, so we're gonna have two examples on how we work this out. So let me remove this one here so we can proceed. There we go. All right, so example number 1. So let me put here example. Oops, let me change color here. Example 1. So here's the example. Identify, oops, the coefficient, which have been the coefficient of each term in the following expression. And the following expression is going to be 7x squared minus x plus 6. So we are going to identify the coefficient of each term. First of all, we will begin by identifying how many terms there are. There are 3 terms first of all. And then we're going to be writing the subtraction as addition of the opposite. So we're going to write here 7x squared plus negative x plus 6. Alright, so here we can see that this has 3 terms, and the terms are 7x to the, oops, wait, I get here 6. Let me put here squared. That's the first term. The second term is negative x, and the third term is 6. The numerical factor of each term is the coefficient, the numerical factor. So the coefficient of this one here is coefficients. Let me put here coefficients. That's the numerical factor is 7. The numerical coefficient here is negative 1, and the numerical coefficient here, well, this coefficient of the constant 6 is simply 6. It is important to be able to distinguish between a term and an expression and the factors of a term. Okay, now we have here example 2. Let me put here example 2. Is m used as a factor or a term in each expression? The expressions are given here. Let me put it here. That is m plus 6, and the other expression will be 8m. So we are going to identify if it's used as a factor or a term in each expression. We'll begin by determining whether m is involved in an addition or multiplication. This is in addition, this is multiplication. So addition symbol separates expressions into terms. This does not separate into terms. A factor is used, a factor is a number being multiplied, which is this one here. So this is a factor. So since m is added to 6, then m is a term of m plus 6. Okay, so let me put here, since m is added to 6, then m is a term of m plus 6. This one here, since m is multiplied by 8, then m is a factor of 8m. That's example 2. So here we can see two examples. First of all, we identify the coefficient of each term in the following expression. They can be separated by putting plus and putting in brackets. M is, and then we're going to identify if the variable or the letter is used as a factor or a term in each expression. As you can see, this is combined by addition, therefore this is two terms. This has two terms, while this is multiplication, so this has one term.